Hi, so here I am with Eric Sun of Facebook. The first question to you, Eric, is how did you come to do social network analysis for a living, and what does that entail here at
Okay,
Facebook?
so I've been at Facebook for about 4.5 years. I started as an intern on the data science team. So over the last 4.5 years, I've done pretty much everything related to data here. I first came here because I was an intern. I was in grad school in statistics, and I wanted to come to a place where I could have my hands on all the data I could ever want and more. So this was a natural place to do it, and I've been here ever since. So in the last 4.5 years, I've done everything related to data from research and analysis to machine learning to building front-end products for users using our big data sets.
Cool. So specifically for this course, though, I'm trying to convince students that knowing about social networks and doing a little bit of analysis is useful. So, which, if any, of aspects of social network analysis have you found useful in your work?
So for my work, I would say that so these days, building front end products with data is one of my primary focuses, and especially now that we have this graph of on Facebook that we call the entities graph, which is everything on Facebook except for the users. So we're already doing pretty well at being like the social graph of people in the world, but we're not doing so well yet at modeling everything else. So I'm talking about the pages and the places people connect to specifically. So with this, we have to, the best way for us to scalably clean up and model this graph is to use crowdsourcing. And when we're developing crowdsourcing algorithms, it's a huge amount of social network analysis to figure out what kind of tasks to send users, what kind of what we can do to use social signals to improve our agreement metrics. For example, like how many yes votes do we need to how many yes votes or no votes do we need to accurately say that something is a good judgment or not, for example. Um, we also use social network analysis to do a lot of things. For example, this paper I'm about to talk about, where, for example, using for search ranking, social signals is one of the big factors in search ranking.
Cool. So, modeling not just the large social network, but the whole world
Exactly.
using social network analysis.
Exactly.
So, without further ado, let's see if we can switch into slideshow mode. Okay, yeah, we're fine.
All right, so now I will talk about a paper that Jonathan Chang, another Facebooker, and I wrote last year on Facebook Places. So this is an example of how we use social network analysis to improve a specific product on Facebook, namely the Facebook Places service, search ranking, and crowdsourcing. So if you're not familiar with it, we have a lot of location-based services now on Facebook, similar to Foursquare. Gowalla, I guess, doesn't exist anymore, but these services all allow users to share their location to their friends. And there's a lot of factors that affect where these users check in, and the idea we had here when working on this paper was to see if we can figure out where people are going to go in the future. So there's a lot of pretty obvious implications for this. One is ad targeting. We can, if we know where you're going to go in the future, maybe we can send you a coupon or do something else that will improve your user experience. If we suspect if we can suspect where you're going to go in the future, we can also use that to improve search ranking in your check-in flow, because maybe you can just press check-in, and then the place where we think you're about to go will just show up on the top. Right, so in order to do this prediction, we use social network analysis to extract a lot of features to use in machine learning. So, for example, we use previous check-ins that you have. We also use all the previous check-ins that your friends have done recently. And as a preliminary data analysis, we used an algorithm called LDA, latent Dirichlet allocation, to group related places. So here we consider it's basically a topic modeling where you treat the users as terms and the words and the places as the words in the document. And if you run this algorithm, then we quickly see that related places pop up very quickly. So here we tried running this algorithm on San Francisco, and when we ran this, some of the topics that popped up were these topics, topic 1, 2, and 3, where topic 1 looks like all places within the Castro district of San Francisco. Topic 2 looks like, I think that's places in the marina in San Francisco. And topic 3 are places that are not really in any specific geographical area, but rather these are all like Asian-themed places within San Francisco. So these are people who check into any of these places are highly likely to check into other places in this group. So it is pretty interesting to see what kind of data pops up just from using a little bit of social network analysis and some unsupervised learning. So just to show some more pretty pictures, so some of the other features we used around predicting check-ins was first demographics. So here in this heat map, lighter areas mean more check-in activity. So if you're familiar with San Francisco, this is a map of the various neighborhoods of San Francisco, and we see that males typically check into the Castro district, which is a very gay-heavy area of San Francisco, whereas the females tend to check in the financial district in do you know what that neighborhood is? North Beach, I think, where a lot of the clubs are, and therefore it's pretty striking how different males and females use Facebook Places. There's also temporal features. So we realized that most of the morning check-ins are around like the financial district where people are just getting to work and checking in. People don't check in nearly as much in the morning as at night on the right side of the screen, where tons of check-in activity are to nightclubs and areas where nightlife is really big in San Francisco. So the next step is to actually predict check-ins. So we do the standard thing in machine learning where we hold out some check-ins and run a regression to try and predict where someone is going to check in next using all these features that I just mentioned. And it turns out we can actually do pretty well. So if we want a recall of 60%, we can actually predict with 90% precision the next place that a given user is going to check in, which was pretty surprising to us, because that it means we're doing pretty well with a large percentage of our data. Not surprisingly, predicting whether someone will comment on this check-in is a lot more difficult, because that's just a lot of noise and a lot of just a lot more randomness. So here we see that with a 60% recall rate, we can only predict with about 6% precision. So this is basically just noise, which was not too surprising. However, we do see there are patterns. So we did notice that responses are much more likely when someone checks in far from your usual location. This is typically when I am going on vacation and I check into, let's say, Hawaii, whereas normally I live in San Francisco. So my friends are much more likely to comment naturally if I'm on vacation in Hawaii. So here the blue line is likes, and the red line is comments, I believe. And the x-axis is the log of distance in kilometers. So the farther away you go, the more feedback you get on your check-ins. Not surprisingly, we also get a lot of boost when someone checks in close to the commenter / liker. So if I live in San Francisco and I suddenly go to, let's say, Berkeley, and I'm now very close to my friend who lives at Berkeley, then they are also much more likely to comment or like my post. This is also not very surprising, and it's good to see these kinds of things borne out in the data. So whenever we're doing these kinds of analyses, social network analysis in particular, or otherwise, it's really important to do enough just background summary statistics and some basic plots to make sure you understand your data and to make sure that your data is sane and correct, and you can figure out if there's any outliers you need to get rid of or anything else you need to clean up before diving into anything deeper. All right, so just to talk about some of these applications. So we have this graph, and right now the big focus on our team is to use crowdsourcing to improve the graph of places by adding metadata and removing removing duplicates. So these are some screenshots of some units we have on our homepage where we ask users like, what kind of place is this cafe in Seattle? We also have a flow where users can add data like categories, name, address, city, town to any place that is not owned, and help us fill out our graph. So there's a lot of really interesting work being done in crowdsourcing in particular, because as I touched on earlier, we want to only accept suggestions that are good. And how do we figure out what's actually good is that we do a lot of analysis to use lots of social features around demographics, around whether you've interacted with this place, whether your friends have interacted with this place, to try and get a sense of whether you are likely to provide good feedback. Because at Facebook scale, we have users of all kinds. We have spammers, we have people who just don't know what they're doing, people who are like very young. 13-year-old girls generally don't provide really good crowdsourcing suggestions, we found. But using these social features, we actually can provide some meaningful lift and figure out what crowdsourcing, how to use social signals to improve our crowdsourcing. So some other applications which I touched on earlier is just better ranking for Facebook places, more ad targeting, and also recommending places you might go in the future. So these are all areas that we're actively working on.
Cool. All right. So thanks, Eric. I think that was a nice broader introduction to data issues and useful applications. So thanks.
Sure. Thanks.